Welcome back to The Explainer. So, if you've been reading the news lately, you'd probably think the electric vehicle revolution is basically running on fumes, right? Well, today we're diving into the actual data. And spoiler alert, the 2026 EV market hasn't stalled out at all. It's actually just matured into this really fascinating new phase. When you step back and look at the hard numbers, from global sales all the way down to commercial fleets, a totally different, highly practical picture emerges. Let's get into it.
All right, let's kick things off with a massive number, 22 million. Despite all those negative headlines you might have seen about slowing adoption here in the US, Bloomberg is projecting a record-breaking 22 million global passenger EV sales this year alone. I mean, that is a 25% jump from 2024. Look, as lithium-ion battery costs keep dropping, plug-in EVs are on track to make up literally 1 in 4 vehicles sold globally this year. So the market, definitely not dying, it's just shifting gears, and the real growth is happening in places you might not expect.
To make sense of this whole complex landscape without getting bogged down in politics, we've broken this explainer down into 5 key reality checks. We're going to cover the global EV divide, the used EV boom, fleets focus on economics, solving the grid puzzle, and finally, software takes the wheel. Starting off with number 1, the global EV divide, and where sales are actually growing. Now, what's genuinely wild about this slide is the sheer geographic divide. Just look at this. China is completely dominating this space with nearly 2/3 of all global EV sales. Meanwhile, Europe is sitting at 17%, and the US, just 7%. So what's actually driving this massive gap? Well, right now, China is literally the only country where EVs are, on average, cheaper to buy right off the lot than your standard gas-powered car. It's a completely different market reality over there, and it is totally reshaping the global supply chain. And this table perfectly illustrates that contrast. Here in the US, shifting policies and fuel economy standards have actually led analysts to downgrade our adoption rates. They're projecting about 14 million fewer cumulative sales by 2030 than we previously thought. But globally, the market is still absolutely surging. Thanks to ultra-aggressive manufacturing and incredibly affordable models pouring out of China, we are seeing massive 25% growth driven by emerging markets like Thailand and Brazil. You know, we used to assume EVs would start in wealthy Western countries and then slowly trickle down. Yeah, scratch that. That idea has been completely turned on its head. Okay, moving on to section 2, the used EV boom and the new economics of secondhand EVs. So here is the absolute crucial takeaway. That massive, scary price premium for electric cars, it has basically vanished on the used lot. Right now, an average used EV is selling for around $34,653. That leaves a gap of just over $1,100 compared to a used gas car. Seriously, just a year ago, that premium was almost $4,000. We are rapidly hitting price parity, which means a lightly used EV can now fit right into the exact same monthly payment bracket as a standard used Honda Civic or Toyota Camry. So why is this happening so incredibly fast? Well, it's all about lease returns. We are seeing a huge wave of about 400,000 total lease returns flooding dealership lots right now, and up to 215,000 of those are specifically EVs. We're talking mostly about lightly used 2022 and 2023 models with super low mileage, and a lot of them are still under their factory warranties. You know that elusive, affordable EV automakers keep promising to build? Turns out it's already sitting right there on the secondary lot waiting for you. Now, before you sprint to the dealership, keep in mind that as an everyday driver, you still have to factor in some sneaky hidden costs that can definitely eat into your monthly budget. First off, because of those giant batteries, EVs are heavy, which means they chew through tires way faster than a gas car. Second, you really need to think about the upfront cost of a home level 2 charger. Getting one of those installed can set you back anywhere from $500 to several $1,000. And lastly, this is a big one. Some automakers are actually locking vehicle features behind software subscriptions, and those might not transfer over to you as the second owner. Gotta read the fine print. Let's shift gears to section 3, fleets focus on economics, moving beyond green mandates to raw total cost of ownership. Now, in the early days, commercial EV adoption was mostly just corporations testing the waters to hit their sustainability PR goals. But listen to this quote from Amazon. By 2026, this is entirely about the raw economics. Fleet operators are looking at the total cost of ownership. And guess what? The numbers actually pencil out. The fuel savings compared to diesel are incredibly tangible, and all those expected maintenance savings, they're totally real. Amazon, which by the way runs over 30,000 electric delivery vans right now, even noted that the software reliability of these vehicles has pleasantly surprised them with amazing uptime.
But as executives from PepsiCo and Amazon have pointed out, to make those economics actually work at a massive scale, you have to ditch your old habits. It's all about strict optimization. You literally cannot afford to keep an idle gas truck sitting in the lot just as a backup for your EV. It's about matching the exact right vehicle to the right route, not just the shortest route, but the route that squeezes out the absolute maximum per mile savings. Oh, and to manage all that insane power demand, fleets are leaning heavily on AI to perfectly optimize their charging schedules. It's a whole new ballgame. Which brings us to a huge hurdle. Section 4, solving the grid puzzle and overcoming infrastructure bottlenecks.
Getting thousands of massive commercial trucks charged up introduces a giant new infrastructure headache. Enter the Megawatt Charging System, or MCS. This is a next-generation heavy-duty solution, and honestly, you have to think of it way more like an industrial power plant than the little charger you'd use for your personal sedan. It is specifically engineered to safely blast an immense amount of energy, up to 3.75 megawatts, into massive commercial batteries as fast as physically possible. To really put that power into perspective, our current fast charging standard maxes out at around 500 kilowatts. MCS can push up to 3,750 kilowatts. That is literally equivalent to the power being drawn by hundreds of average homes, all at the exact same time. In practical terms, it means you can charge a monstrous 600 kilowatt-hour truck battery to 80% in under 30 minutes. This is an absolute game changer. It means electric long-haul routes are finally commercially viable because drivers can just juice up completely during their standard legally mandated rest breaks. Now, there is a catch. Plugging in megawatt chargers usually means waiting years for the utility company to upgrade the local power grid. So to bypass that multi-year nightmare, fleets are getting smart. They're installing what's called Battery Energy Storage Systems, or BESS. Think of these as giant behind-the-meter buffer batteries sitting on site. They quietly sip cheap power from the grid during off-peak hours at night, and then they discharge it super rapidly during the day to feed those massive truck chargers. It's brilliant. It lets fleets scale up their EV operations today without blowing their power budgets or waiting forever on the power company. And because this grid bottleneck is such a massive issue, we are seeing serious private capital stepping in to solve it. Take Uber, for example. They're dropping a cool $100 million to build roughly 1,000 high-powered DC fast charging points. And get this, they aren't just doing it to be nice to everyday drivers. They are locking down this infrastructure for their future autonomous robo-taxi fleets. I mean, think about it. Self-driving cars don't have a human driver who can sit around waiting for the car to charge for an hour. They need guaranteed hyper-fast turnarounds to get right back on the road and keep generating revenue. Finally, let's zoom in on our last point. Section 5, software takes the wheel. The very definition of a car is completely changing. If you looked at the recent Beijing Auto Show, one thing was crystal clear. Just making a car electric? That's old news now. The real battleground today is code. Automakers are rolling out AI-native vehicles that function as continuous learning ecosystems. The car is becoming less of a mechanical tool and way more like an intelligent companion. We're seeing centralized computing brains completely replace dozens of clunky separate control units. And fascinatingly, automotive parts suppliers aren't just stamping out basic metal and plastic anymore. They're literally co-designing the core brain-level capabilities of these vehicles. And this shift in focus is causing a massive competitive inversion. S&P Global actually projects that by 2027, automakers in Greater China will overtake North America in in-house software development efforts. Because they are leaning so hard into deep software integration and national AI strategies, Chinese firms are aggressively challenging Western legacy brands. They're offering insanely advanced digital systems, and they are climbing straight up into the premium luxury segment. Which leaves us with a truly fascinating reality to chew on. We are looking at a future where a car isn't just a standalone mechanical product anymore. It's essentially a continuously evolving computer on wheels, plugged right into a much larger digital world. So, as the very concept of luxury gets redefined by sleek lines of code rather than shiny strips of chrome, can traditional legacy automakers actually adapt and survive the software era? Or will big tech companies eventually inherit the road? Thanks so much for joining us on this explainer, and remember, keep questioning the data.